Before we start with our discussion this morning or this time, I'd like to share this quote from Winston S. Churchill. Success is not final. Failure is not fatal. It is the courage to continue that counts. So, good morning once again, my dear students, and welcome to another discussion in environmental science, particularly uh, the lecture 7, the dynamics of the biological populations and the properties of biological communities. So we are going to discuss the dynamics of the biological population. We are trying to investigate the changes between population and of course its attribute to the physical environment or to the ecosystem. So before we proceed with our activity or this discussion, I'd like to present to you the learning outcomes. So at the end of the lesson, the student should be able to use basic concepts in examining the factors that affect the distribution and abundance of animal and plant population. And the next one is state the significance of the community in ecology and describe types of community interaction. Now, we shall begin with studying what is population ecology. So basically, population ecology is the study of how the environment affects a group of animals or plants. So it looks at how many of them wherein there is a certain area called population density, and of course meron tayong tinatawag na population distribution where they live and also how old they are. So environmental things like food and weather can change these numbers or factors and affect uh, the state of population. So take note, class, that population ecologists study these changes to understand how the environment influences the size and characteristic of a group of animals or plants in nature. So that is population ecology. At this point, there are different characteristics of the population ecology. So these are population size, population density, dispersion, the patterns of population. Of course, we should also include the demographic, the survivorship curves, and of course, the population growth. Let's talk about the population size. So, population size, uh, in population genetics and population ecology, the population size, usually denoted N, is the number of the individual organisms in a population. So the factors that governs population size are the following. So we have here the CBR, or the crude birth rate. We also have the crude death rate. We have the immigration and immigration. So take note that these factors, along with birth, death, and the movement of individual into and out of the population, collectively determine the overall population size. And take note that understanding how these factors interact is essential for studying population dynamics in genetics and ecology. So these are the factors that governs population size. So we have natality. When we say natality, it refers to the birth rate, which is a measure of the number of live births within a specific area over a set period of time. So uh, it's often expressed as a ratio of the total live birth to the population. So it helps us to understand how many new individuals are being added to a population in a particular region. So we also have mortality. When we say mortality, it refers to the death rate, which quantifies the number of deaths within a defined population over a given time frame. So it's usually expressed as a ratio of a total number of deaths to that total population. So mortality rates provide insight in the number of individuals leaving the population due to death. So both natality and mortality are crucial factors in the population dynamics and demographics of the population. So next we also have immigration. So when we say immigration, it terms used to describe the number of the organisms or individuals moving into an area that is already occupied by a particular population. So meaning to say, it's a process of new individuals coming into the population's habitat or territory, potentially increasing the population size. Kapag may dumating sa isang community, it is a type of immigration. So kapag immigration naman, when we say immigration, it refers to the number of the organisms or individuals moving out, okay? Moving out of the area that is currently occupied by the population. So immigration, take note that immigration rather results in a decrease in the population size as individual leaves a population habitat or a territory. So that is the difference between the immigration and immigration. So generally, it results to these two things are the factors that governs population size. So these are attributes or these are dynamics of the population in a particular community. So moreover, these are the factors that increases the population size. So when we are pertaining to the increase in population size, we are pertaining to the natalities, the birth rate, and of course, the immigration. Ibig sabihin, ito yung paglipat, okay? Paglipat ng mga animals in a particular what do you call this? Yung halimbawa pagdating, okay? Pagdating ng mga animals in a particular territory. So kapag naman magre-reduced, okay? Ito yung kapag reduced ang population, ito yung mortality or the death rate, of course, that could be caused or that could be caused by predation, some other diseases or other environmental factors, and of course we have the immigration where individual leaves the population for another habitat. So kapag umalis at kapag may namatay, that reduces the population, it reduces the population size. So kapag may dumating at pag may naipanganak, that is an increase in population size. So if we try to look on this illustration, we can identify the difference between natality, mortality, as well as the immigration and immigration. So when we say immigration, ito yung pagdating in a particular location or a territory, and kapag ka-immigration, ito yung pag-alis. Okay? So we have the birth, yung of course, the natality, it's an increase of the population number in a particular species, and of course kapag may death, of course it's a cost of the death of a specific species that may result to population what do you call this, magdi-decrease ang population natin. So these are the parameters that affect size or density of a population. Okay, so take note of these formula. We have population change is equal to the birth plus immigration minus death plus immigration. So kapag ka nagdagdag, we have natality, and kapag ka may immigration, that increases the population size. Kapag ka immigration, umalis, may umalis, okay, immigration. So kapag may umalis and kapag may namamatay. Okay? So how to compute the population change? As mentioned earlier, n is the change in population. Okay? So this is the formula. So n is equal to b plus I minus D plus E. So N is the change in population, D is the number of birth, and I is the number of immigrants or people or organisms that have moved into the area. And D is of course the number of the vet organisms, and of course we also have the E, which are the number of immigrants or the number of people who have moved out of the area. So let's try to do these, or let's try to solve these examples. So let's take a look at the examples population. So let's say, say you want to know the change in the population of your town over the past 2 years. So your town currently has 20,000 people, but you don't know how people it had 2 years ago. So however, town record shows the number of births, that immigration and immigration. So these are listed below. So we have here a data: 2,000 for birth, 700 for new residents who immigrated, and there are 1,500 organisms na namatay, and of course 800 na nag-move away. And let's try to compute this. So taking this information and plugging it into the formula given to you, we have N is equal to 2,000 plus 700 minus 1,000 500 plus 800. So upon plugging this information, you can actually solve it by of course doing basic calculation, okay, by adding, subtracting these numbers. So you can actually get this information. N is equal to 2,700 minus 2,300, and it is equal to 400. So the change of population over period of time is equal to 400 people. That means in 2 years ago, the population was 19,600. So pwede mo lang siyang i-deduct. Okay, so that is the very good example of how the population change in a particular location. So let's talk about population growth. So when we say population growth, it is an increase or decrease of population. So generally, it is controlled by the rate of which new individuals are added to the population. So we are pertaining to the natality or the birth rate, and the birth rate at which individual leaves the population. And of course, we also consider the death rate. If we try to consider the growth of the population, okay, of course, we must also consider the death rate in order for us to conclude kung nagkaroon ba ng addition or meron bang subtraction sa ating population in a particular community. Now, we have here types of population growth. We have the exponential growth and the logistic growth. So we have here the two types. So when we say exponential growth, this type of growth occurs when population increases rapidly. Okay, take note of the rapid or extreme rapid increase at a constant rate. So take note that if a population has a constant birth rate through time and is never limited by food or disease, of course, mag-i-increase ang population in a constant rate. So that is an exponential growth. So when we say logistic growth, it does have a period of exponential growth, but will stop or slow down. So it is because of different factors that could be space scarcity, okay, food scarcity, water scarcity, and other environmental factors that could actually affect the population growth. Okay, so let's try to analyze these. Okay, so if we try to analyze the exponential growth, it is a rapid constant increase of the of the population. So, constant lang siya. As you can see in this illustration, di ba? So, pataas lang siya. So, when we say logistic growth, it has something to do with a carrying capacity of the environment. When we say carrying capacity, of course, we are pertaining to a number of, or a certain number of species wherein our environment could actually cater. So kung halimbawa konti lang ang as mentioned earlier, if water and other types of environmental things are not present in this particular location, maybe these are the factors that may alter the continuous increase of this population. So that is the logistic growth. So it has something to do, or it is governed, or it has something to do with some other factors such as physical environment, and as well as the uh, chemical elements that could actually affect the population growth. Okay, so we also have here the survivorship curves. So when we say survivorship curve, one way to characterize a population is with regards to how the chances of survival of an individual in population change with age. So we have here the survivorship curves. So these are plots of numbers of survivors versus relatives age. So we have here type 1 curve, type 2 curves, and type 3 curves. So when we say type 1 curves, it applies to population in which individuals are likely live out their potential lifespan. Take note of that. Live out their potential lifespan. So we have here type 2 curve. We have here it applies to population in which mortality rates are constant throughout age classes. Take note of the mortality. So when we say mortality, we are pertaining to the death rate. So there is a consistent or constant increase of the death rate when we are pertaining to the type 2 curve. And when we are referring to the type 3 curve, it applies to population in which mortality rate naman are the highest for the youngest cohort. Okay, so let's take a look at this example. So uh, we have here the type 1 curve. Okay, so type 1 curve, this curve is a population where individual tends to live a long time, and most of them survive until old age. So it's like a gradual slope what they call it, it's like a gradual slope upward, showing a higher chance of survival for most of life. So a very good examples are the human population. Okay, so we have here also the type 2 curves. So this one is for population where the risk of dying is about the same for individuals of all ages. So it's a straight line indicating a fairly constant chance of a survival of different ages. So take a look at this. Diba? It's a straight line. So, of course, a very good examples are the lifespan or the survival rate of some rodent population. And of course, we also have here the type 3. Okay? So, in this case, we can actually say, or you can analyze that the population has the highest dying risk. Kasi di ba, na-decline yung kanilang, as you can see here in the graph, as time passed by, the number of survivors are decreasing. And of course, the as they age, nagde-decline yung kanilang population. So take note that in this case, the population has the highest risk of dying when they are very young, and the chances of survival get better as they get older. So it looks like a steep drop in the beginning, ito. So and this curve is atypical for species where many young individuals may not survive to survive to adulthood. So ito yon. So So, ano nga ba yung implication nito? So, this curve helps scientists understand the survival patterns of different populations, whether most individuals live a longer time and the risk is constant, or if young one face the higher danger. So, now, I hope na naintindihan niyo yung curve na yan. So, let's talk about the population density. When we say population density, it is a measurement of the number of people in an area. So, it is an average number. Okay? Take note, it is an average number. So, it is usually known as the number of people per square kilometer. And the population density is equal to the population divided by the area. Take note of that. And we can actually plot this in this formula. Okay, so the unit of the land area should be square mile or square kilometer. So the unit of the population density is per unit area, and a very good example of this is 200 people per square mile or 200 people for square kilometer or square mile. Okay, so we are pertaining to land area. So what is the unit of land area? That could be mile, that could be kilometer. So that could be square mile or that could be square kilometer. Okay, so that is population density. So how to compute the population density? So a very good example is these. There are 145,000 people in the city of Auburn, and then the urban area covers 9 square miles. So if we try to divide 145,000 people to the 9 square miles, we can actually get the population density, which is 161,111 per square mile. So that is very easy to compute. So next, we also have the density or measurement of density. So density is measured by two methods. We have here total count method and of course the sampling method. So when we are pertaining to the total count method, it is a way of counting the entire population of a particular group of a species. From the word it said, magka-count ka lang ng species. So it's possible for a few animals or organisms that are relatively easy to observe and often used for breeding colonies. So in this method, you can actually photograph of a colony and then count the individual in a photos later. So like for example, ano mga ba yung mga animals or species na kaunti lang ang population? Pwede mo yung bilangin. Okay, we have tigers, lion kapag pupunta ka sa savannah, okay, or sa mga grassland. We have cows, diba? So of course, we can actually count the human population census trees in a given area. Okay, that is a total count method. And we have here some sampling method. So it depends on type of organism and its natural abundance and distribution. So we have here two broad categories. We have the plot-based method and the capture-based method. So when we say plot-based method, or yes, the quadrant sampling method, we are pertaining to, of course, we can actually do this by simply plotting it using this formula. Okay, we have total population is equal to the average number per quadrant, which is the mean, times the total area of the quadrant. Okay, so it is widely used in plant studies because of course it's really hard to count the numbers of grasses. That's why we could actually measure the number of population in a particular location by simply doing this. Hindi mo siya pwedeng i-count, diba? It's really hard to count all the grasses. So quadrant sampling method could be used. Okay, we also have the mark recapture method. So when we use the mark recapture method, it is used for a very mobile or elusive species. Okay, it is first used in the 1980s by C.G. Peterson to estimate the fish abundance. So generally, like for example, so a sample of individual from a population is captured. Okay, so ito na yung mga yon. So now, it marks some other way. So, natag na sila. Okay? So, they could be painted or tagged. Okay? May mga tag na sila. Then, i-release na sila sa ocean. So, if they try to catch more fish and observe the proportional tagged, we can say that there you can actually analyze that of course, after a period of time, another sample will capture. So this second sample includes bark marked and unmarked individuals. So by analyzing the ratio of this what they call this, mark species to the total number of the second sample, you can actually estimate that population size. So this is based on the assumptions that the proportion of the marked individuals in the second sample is representative of the proportion of the marked individuals in the entire population. So next, we also have here a very good example of the mark recapture method. Okay, so if we try, so these turtles are being marked, and then nagkakaroon ulit sila ng other on the second capture. Of course, merong mga species na hindi na mark. So here, kapag i-ratio nila itong mga to, they can actually identify the population, or they could actually estimate, okay, not estimate kasi it's not the exact value, okay, so they could actually estimate the number of population or organisms in a particular location, okay. So why is it important to know the population size or population density? So take note, class, that knowing the population size is important in making environmental decision that would affect the population. So the changes in the population can affect how the population interact with physical environment and with other species, because these are all essential in our environment. So by tracking the population over time, ecologists can see how these populations have changed and may be able to predict they're likely to change in the future. Because if it happens that a number of species is nagde-decline, maaaring mag-conclude yung mga environmental ecologists natin that these species may be extinct, or these species may be endangered, and of course from that they can conclude that, or they could actually make rules or policies that governs or regulates the lives of this particular species. So hindi lang pwedeng pabayaan natin yung mga species na nawawala, because as we go back to the principles of ecology, they have a particular function, they have particular roles na ginagawa sa ating community or sa ating ecosystem para ma-balance yung tinatawag nating ecological equilibrium. And of course, here, we have here the dispersion of the population. Okay, from the word itself, dispersion. So the dispersion of the population refers to a new individuals within the population, or a range. Okay, the arrangement of a population, or of course we are referring to the spaces present in their geographical location. So it actually described the pattern of the distribution. Take note of that. The distribution of the individual, and help ecologists understand how organisms are distributed in a particular habitat. So we have here clumped, we have here random, and we have here uniform. Okay, so let's talk about clump, random, and uniform. So when we say clump dispersion, we are pertaining to the individuals aggregated in a patches. Okay, take note of the patches. Okay, so when we say patches, patches are of course some area of the habitat are more suitable than others, and of course heterogeneous environment with resources concentrated in patches. So parang there is a particular location in a particular there is a particular area in a community na parang may parang hotspot na doon lang sila tumutubo. Parang ito yung patches, okay? So it's attend of course, generally, if we try to discuss about this, we can say that they organisms are being or are dispersed through or are grouped together in patches within their habitat. Okay, next, katulad nito, okay? So here, these are some patches na tinatawag natin, okay? So ito yung mga patches wherein dito talaga nag-grow yung mga plants, okay? Or dito nag-i-stay yung mga organisms. So for many animals such as wolves, living in groups increases the effectiveness of hunting and spread the work of protecting and caring for young. Okay? It helps exclude other individuals from the territory. Parang ganito din yung mga isda, 'di ba? It's their defense mechanism. 'Di ba yung mga maliliit na isda nagka-clump together, okay? They are in group. Hindi kasi kapag in group sila, mas malaki silang tignan. At kapag mas malaki silang tignan, of course, parang matatakot yung mga ibang predator na kainin sila kasi nga mas malaki yung group of species nila. So, di ba? Dito, they stay together. Sana all. So, next, we have here the uniform dispersion. So, when we say uniform dispersion, it is evenly spaced distribution. Okay? Take note of that. It is evenly spaced distribution. Pasensya na ako sa highlighter ko. Natiwang na siya. Okay? Balik tayo sa yellow. So, evenly spaced distribution which members of the population maintain a minimum distance from one another. So, kung titignan mo, parang ito yung mga population dun sa maisan or sa cornfield, 'di ba? Meron silang specific distances, ganon. Okay? They are being uniformly distributed. So, ito, 'di ba? They are uniformly distributed. Okay? So, sa ating environment, we have the rice, 'di ba? We have the, what do you call this? We have the rice, we have the corn. Kasi itong mga plants ito, hindi mo pwedeng itanim kung saan-saan kasi maaaring hindi sila mag-survive. So, that is uniformly distribution. And of course, we have here penguins, okay? Birds nesting on small islands such as these king penguins on South Georgia Islands in South Atlantic Ocean often exhibit uniform spacing and maintained by aggressive interaction between neighbors. Diba? Sana all, they are uniformly distributed. Okay, we have here random dispersion. Kapag random, of course, random lang siya, pakalat-kalat. Parang mga gamit nyo sa bahay na nakakalat lang. Okay, it is spacing patterns of on a total unpredictability. Least common patterns of distribution. And, of course, members of the species do not frequent interact with one another. Kasi nga, pakalat-kalat lang sila somewhere else, okay? Not heavily influenced by microenvironment within their habitat. So, a very good example is these. So, dandelions grow from wind-blown seeds that land and random and later germinate. So, like for example, yung ating mga grasses, minsan, di ba, pakalat-kalat lang sila somewhere else. Yung iba kung saan-saan tumutubo just to survive. So let's talk about the different limiting factors that actually limit the growth of the population or actually has an attribute or it's an attribute of the population. So of course, these are the factors that causes the population to decrease, okay? So to become stagnant, we have here the density dependent factor, and of course, we have here the density independent factors. So when we say density dependent limiting factors, these are factors that depends on the size of the population. So we have here mutualism, commensalism, parasitism, predation, and competition. So when we are pertaining to mutualism, it's generally a positive interaction. In some cases, it can actually lead to resource competition, limiting growth or population growth. Okay, so when we say commensalism naman, it's similar to mutualism. So some forms of commensalism may indirectly impact the population, so affecting, of course, the other organisms. So parasitism, the presence of parasite can actually reduce the health and survival of the organisms of the population. Okay, we have here predation. So kapag nakain yung prey, of course malilimit yung growth of population. And of course competition, kapag may competition, of course merong parang dito, no, parang characteristic ito ng, of course, pagkain ng ibang species wherein other species may not grow already. And of course, we have here density independent limiting factors. We have natural disasters, weather, and human activity. So these are actually one of the factors that really decreases the population of the ecosystem or the population of a particular territory. Okay, so we have here natural disaster. Of course, kapag bumagyo, masira lahat. Okay, so nawala lahat. Okay, kapag weather, it is actually the presence of the physical elements. Of course, these are the factors: the presence of the sun, the moisture, the water amount, the precipitation. Okay, and of course, human activities. Kapag masyado tayong greedy, okay, kapag masyadong maraming mga ginagamit na resources, maaring these are the factors that actually causes the population to decrease. And of course, now from that, let's move on to the community interaction. So when we say community interaction, it's basically the interaction of the community. So generally, what is a community? So in a community represent a living component in an ecosystem. So it consists of the population of the different species and live in the same area. So we have here, this is a community because there is a population of giraffe, there are population of plants, and there are population of zebras. Okay, if we combine all of these, you can create community. So species interaction with communities are important biotic factors in natural selection. So when we say natural selection, it's basically the adaptation or the survival of the fittest. Okay, so in the interaction helps shape the evolution of the interacting species because diba, each of these organisms are relying to each other. Okay, diba? They are all interconnected to everything else. And of course, three major types of community interactions are, of course, predation, competition, and symbiosis. So this is a community. So of course, the first community interaction is through predation. Predation is one thing that actually alter the growth of population. So predation is a relationship in which member of one species, the predator, consume member of other, which is the prey. So predator-prey relationship accounts for most energy transfer in the food chains and food web. Okay, so this is a classic example of predators and prey. So of course, kapag yung lion kinain yung halimbawa yung ibang animals such as yung cow or other species which is na prey niya, na pagkain niya, of course, it's a type of predation. And of course, we have here true predation. So when we have here true predation, it is a type of predators. Okay, true predation is the predator kills the prey. Okay, so that is true predation. So some true predators like lions catch large prey and then dismember and chew their prey before eating. So other true predators can catch small prey and swallow it as a whole. So like for example, ito, that this is true predation because it actually, the snake will swallow mice the whole. Okay, we also have here grazing. Take note that grazing is also a predation, o di ba? A predation, it's part of its prey but rarely kills it. Of course, di ba, kapag tayo, kukuha lang tayo ng talbos ng kamote, it's basically predation. Okay, some predators are not true predators because they do not kill their prey. So instead, they graze on their prey. Because plant is also an organism. And kapag kayong herbivores such as these deer graze on plants, yung plant, hindi naman siya actually mamamatay. Okay, part of plant lang, mababawasan, but as time pass by, mag-grow din yun. So that is parang grazing is a part or a type of predation. So next, we have here community interaction. So community interaction has something to do with predation and population. So true predators helps control the size of prey population kasi kapag walang predator, dadami ang prey. Okay? Kapag walang prey, walang predator. Okay? Or kapag dumami ang predator, of course, maaring maubos ang prey. So, there must be an equal distribution, or there must be actually an equal size between prey and predator. Okay, I'm not pertaining to an equal size, but of course, an exact ratio between predators and prey. So this is especially true when a predator preys. This is especially true when a predator preys on just one species. So generally, the predator-prey relationships keep the population size of both species in balance. Okay, di ba? Nababalance siya kapag walang predator, as mentioned during our previous discussion. Kapag walang predator, dadami ang mga prey. Okay? Okay, like for example, yung mga herbivores. Dadami ang mga herbivores. Dapat kapag dumami ang mga herbivores, maubos ang mga autotrophs natin, which are the plants. Okay, so these are their functions in the ecosystem. Okay, we have here the keystone species as type of the predation, and of course maintains the population. So some predator species are known as keystone species because they play such important role in community. So of course, introduction or removal of a keystone species has drastic effect on its prey population. So these in turn affects populations of many other species in the community. So a very good example of these is of course the presence of the starfish. Okay, so some starfish species are keystone species in coral reef communities. So the sea star prey on mussels and sea urchins, so which have no other predators or natural predators. So, itong kasing mga mussels na to, okay, yung mussels and sea urchin, parang walang masyadong kumakain sa kanila maliban sa tao, di ba? Itong mga to is kinakain ng tao. So, just to maintain their population, of course, what they do is, the keystone species do is parang sila yung mga natural predator ng mga to. Okay? If sea star are removed from the coral reef community, mussels and sea urchins population would have explosive growth. So, dadami ang mga mussels and sea urchin, which in turn would drive out most of other species and destroy the coral reef community. So, maaaring sila yung dahilan para, of course, magiging unbalanced yung ating ecosystem or yung population sa particular community na yun. Okay? So, next, we also have here adaptation to predation. So, both predators and prey have adaptation to predation. Of course. So, lahat tayo, we should adapt to our environment in order to survive. So, parang ganun din ang mga animals natin. They are adaptation to predation. So, kasi kung hindi sila mag-adapt sa kanilang environment, maaari silang makain agad-agad. Okay? Predator adaptation help them to capture prey, and prey adaptation help them to avoid predators. So, we have here camouflage or disguise. So, di ba, katulad ng
mga sundalo natin. Bakit kaya ganun yung suot nila? Okay? Yung parang camouflage na uniform ng mga sundalo because they are trying to disguise kapag nag-blend sila sa environment, parang hindi sila masyadong mahahalata ng mga kalaban nila or ng mga enemy nila. So one way is using the camouflage is of course to blend with the background. Okay? Take note of the blend with the background. So another way of using camouflage is to look like different or more dangerous animals. So take a look at this. So can you see the crab in the photo on the left side? So hindi mo siya mahahalata kasi para lang siyang bato, 'di ba? Para lang siyang bato. So it is camouflage with algae. So the praying mantis is in the middle of the photo, looks like the dead leaves in the background. So asan yung praying mantis dyan? So ito yung praying mantis. Okay? So ito yung praying mantis na para lang siyang nag-blend sa tawag nito, sa kanyang background na parang hindi mo mahalata na nandun siya. Okay. So the stripes on the zebras in the right photo blend the animals together, making it hard to see where one zebra ends and other begins. Diba? So parang it's their defense mechanism in order to prevent predators. Kasi kapag halimbawa yung isa dyan humiwalay, maaaring siya yung target ng mga predator. Okay? At kapag siya ang naging target, maaaring siya ang pagkain ng mga lions or mga tigers, which are some predators of these zebras. Okay? We also have here the mimicry. Mimicry appears or use Mimicry is using appearance to mimic other animals. Okay? So some prey species have adaptations that are opposite to camouflage. So they have bright colors or other high noticeable traits that serve as warning for their predators to stay away. So for example, some of most colorful butterflies are poisonous to birds. So birds have learned to avoid eating them by being so colorful. The butterflies are more likely to be noticed and avoided by their predators. So katulad din yan ng mga tawag nito, ng mga mushrooms natin. Okay? Most of the mushrooms are yung mga edible mushrooms natin, sila yung mga brown, yung mga yan, yung mga edible mushroom natin, or yung mga white lang, ganun. Pero kapag colorful yung mushroom, maaring it contains toxins. Okay? Kasi these are some of their defense mechanism para hindi sila makain. Okay? So, take a look at this example. So the moth on the left mimics the owl on the right. So of course, paano nangyari yun? Kasi parang minimimic niya yung mata ng owl. So when a predator comes near, the moth suddenly displays the marking. So this startles the predator and gives the moth time to fly away. Okay, 'di ba? Napakaganda ng kanilang adaptation sa predation. So next, we have also here predation, natural selection, and coevolution. So these are some of the community interactions. So take note, class, that adaptation to predations comes about through natural selection. Because if you cannot adapt to your environment, you can survive. Okay? When a prey organisms avoid a predator, it has higher fitness than members of the same species that were killed by the predator. So ibig sabihin yan, you have higher chances of survival kapag you have adaptation to your environment. So the organism survived longer and may reproduce more offspring. So as a result, traits that helped the prey organisms avoid the predator gradually become more common in prey population. So, dito na nasusustain yung population nila. Okay? So, kasi wala silang ganitong type of adaptation, maaring hindi sila makakapag-survive sa ating environment kasi maaari silang makain na lang basta-basta ng mga predators. So, take note, we also have here the coevolution. So, when we say coevolution, evolution of traits in the prey species leads to evolution of the corresponding traits in the predator species. So ito yung mga yung pag-adapt nila sa kanilang environment has something to do with their co-evolution. Okay? So ito na yung mga parang mag-e-embody sa kanilang mga species na kung saan ito na yung parang may ipapasa na for the next generation. Okay? At of course, ito na rin yung mga ways nila or mechanisms nila to survive their environment. We also have here competition. So when we say competition, it is a relationship between organisms that strive for same limited resources. So the resources might food, nesting site, or territory. So of course, katulad lang ng mga tao katulad lang ng mga tao yan. Of course, we are looking for food for survival. So, of course, kapag halimbawa, may namibigay ng bigas, may competition yan sa mga tao. Of course. So, kapag ka nakakuha ng bigas, of course, makakasurvive ka. Mahaba ang buhay mo. Pero kapag hindi ka nakakuha ng bigas, okay, maaring magutom ka at maaring ito yung cause ng pagkamatay mo. Okay, we have here two specific types of competition. We have the intra and the inter-specific. So, when we say intra, you are in compete with your same species. Okay? Kapag ka naman inter, with other species naman siya. Ganun lang 'yon. Okay? Ganun lang yung intra and yung inter and intra competition natin. Okay, we also have here symbiotic relationship. So when we say symbiotic relationship, we are pertaining to the symbiosis, okay? Living together, any type of close and long-term biological interaction between two biological organisms. Okay, as mentioned earlier, these are the dependent limiting factors of the environment. Okay, we have here mutualism. So, when we say mutualism, both species are benefited. Okay, lichen is a very good example. So, we also have here commensalism. So it is a symbiotic relationship in which one species benefit while the other species are not affected. So a very good example of this is of course yung tree at saka yung orchid, di ba? They are interacting to each other. Yung orchid na benefit sa of course sa trees kasi yun yung kanilang habitat. And of course, we have here parasitism. When we say parasitism, one species or the parasites benefit while the other species, the host, is harmed. Okay, katulad ng mga tawag nito, yung mga parasites sa loob ng katawan natin. If ever na may mga parasites, 'di ba? Mga worms. Okay, hindi natin alam. May mga worms tayo sa loob na unti-unting kumakain sa mga kinakain natin. So, tayo yung host at yung parasite is nabe-benefit. Okay? So, that is what they call this. That is the symbiosis. Okay? We also have here ecological succession. When we say ecological succession, it occurs the following disturbance that create unoccupied areas for colonization. Take note, a disturbance that create unoccupied areas for colonization. So, the first colonizer species are called pioneer species. Kapag nakakita kayo ng pioneer, meaning to say that we are referring to the first. Okay, sila yung mga nangunguna. Okay, they change the environment and pave the way for other species to move into the area. And succession occurs in two different ways depending on the starting condition. We have here primary succession. So, when we say primary succession occurs in an area that has never been colonized. Okay? So, generally, the area is nothing but bare rock. This type of environment can sum about the number of ways including lava flow from the volcano, the glacier, okay, and of course the landslide uncover the land area of the bare rock. So after the disturbance, pioneer species move in first. So ito yung of course sila yung mga nangunang mga species na tumubo doon. We have primary succession. After these we also have secondary succession. So, kapag may mga nangunan, secondary succession occurs in formerly inhabited area that was disturbed already. So, the disturbance could be fire, flood, human actions such as logging or harming. So, kapag halimbawa, nagkaroon ng merong specific area na hindi siya na inhabit before dahil nasunog, like for example yung grassland natin, 'di ba? Kapag yung nasunog siya, maaring magkaroon ulit ng regeneration of plants. Okay? So, yung regeneration of plants na yun, maaring yun yung tinatawag nating secondary succession already. Kasi meron ng mga nanguna, okay, na nagstay doon or nag-thrive doon. We also have here the climax community. So, when we say climax community, climax communities were once thought to be parang final stable stage of ecological succession. Parang ito yung pinaka-stable na parang marami ng mga interactions doon. So, hindi na siya maaring mawasak pa. Maaring mawasak siya due to weather conditions and natural disasters. But, kapag na-meet na itong climax communities na to, magiging sustainable na siya, yung ecosystem. And of course, magiging balance na yung mga interactions ng species doon. Okay? So, the type of climax community may believe to be determined mainly by climate. So, climax communities were also thought to be biodiverse. Katulad nga ng sinabi ko kanina, mas marami ng mga species doon. Kapag biodiverse na siya, ibig sabihin marami ng mga plants and animals na nandun, magiging sustainable na siya. Okay? So, magiging stable na siya and resistant to change already. And high biodiversity may increase species interaction. This is in turn may species more interdependent and communities more likely to change when they are disrupted. So, ano nga ba yung mga maaaring mag-disrupt sa community na stable na? Okay, we have, of course, the human activities. Maaaring sa isang stable community, like for example, yung forest natin, it's an stable community, or it's an stable, yes, maging stable na siya. So, maaaring ma-disrupt yun due to human activities. Okay. So, that is the end of the lecture, and I hope na marami kayong natutunan from our discussion this time.